Good day, everyone. You are welcome back to Idowu Math class. This is another day. Let's consider this example 3. It looks different. If 3 root 5 is equal to square root of p, find p. What are you expected to do? Simple indices. Here, this is just simple indices. Do in Surds. You rewrite it as root p equals 3 root 5. You are writing the same thing. To get the actual value of p, since it is the square root that is the problem on p, we use the power 2 to solve the problem. When square root poses a problem, power 2 solves it. When cube root poses problem, power 3 solves it. How? Square both sides. That is to say, take power 2 of both sides, which is square root of p all raised to power 2, which is equal to 3 root 5 all raised to power 2. This cancels this in mathematics. The reason behind it is that square root of p means p raised to power half. And p raised to power half, that is raised to power 2. These two will cancel these two to give us ordinary p raised to power 1, which is p. So that's why we believe this cancels this. So we have p being equals to 3 square times 5. Do you know why? This is 3 square times root 5 square. 3 square is here. This will cancel this to give us 5. So p equals 9 times 5. P equals 45. That is it. Let's see this example 4. It's also unique. It's just the manipulation of simplification of Surds. Write 7 root 3 as a single number under square root. What are you expected to do? Whenever you see a question like that, simply square the number given to you. That 7 root 3 given to you, square it. When you square it, put another square root on your solution, and that's the answer. In case of the objective, just do that straight away and you get your answer. So, the number is equal to square root of 7 square root 3 square. Now I've told you, just square this and put square root on it. I have already put the square root on it. Then I have squared each of them. I've squared each component under the root. So we have square root of 49 times 3. 7 square is 49. Root 3 square is 3. I've told you the reason, the rationale behind that. Square root of 3 means 3 raised to power half. Therefore, 3 raised to power half times 2 gives 3, which is the same thing as square root of 3 raised to power 2, in which we believe that this cancels this to give 3. I hope my explanation is clear to you. So, this gives us 49 times 3. That is 147. That is it. Let's go to rules of Surds. Number 1 rule we have there is the rule of multiplication of the like sort. When you have root b to multiply root b, the result is equal to b. E.g., if you have root 9 times root 9, The result is 9. There is no much to that. If you have root 2 times root 2, the result is 2. When you multiply 2 like surds together, you get the value under the square root as your answer. Number 2, square root of p times square root of n gives square root of pn, because they are not like surd. So, e.g. is when you have square root of 2 times square root of 5, the result will give you square root of 10, because they are not like surd. So it cannot be like number 1. That is square root of 10. So another one is number 3, addition, the rule of addition. Square root of p plus square root of p gives 2p. It's just like you pretend you are having coefficient of 1 here, also coefficient of 1 here. So when you add 1 to 1, you get 2. So 1 square root of p plus 1 square root of p gives you 2 square root of p. E.g., you have root 3 plus root 3. This gives you 2 root 3. Also, you have root 5 plus 3 root 5. This gives 4 root 5. Because we believe the coefficient of this root is 1. So 1 root 5 plus 3 root 5 gives 4 root 5. It's a simple thing. Let's come to subtraction. 3 root m minus 2 root m gives root m. It simply means when you subtract 2 root m from 3 root m, it gives you only 1 root m, which is root m. Root m is the same thing as 1 root m. It's only you don't need to put that one there. If you put it there, it shows you as an amateur. So, e.g., you have root 7 minus 3 root 7. That gives minus 2 root 7. Hope you understand how. 1 root 7 minus 3 root 7. Just take 1 minus 3. What is 1 minus 3? 1 minus 3 is minus 2. So that gives you minus 2 root 7. That is that as introduction into the rules of surds. Let's see how we apply the rule further. Now we come to addition and subtraction of surds. Example 1. Simplify root 18 plus root 8. Don't do like some people do. They will say root 18 plus root 8 is root 26. Novice people, don't do that. Simplify root 18 to be root 9 times root 2 plus you simplify root 8 to be root 4 times root 2. This gives us square root of 9 is 3. 3 times root 2, that is 3 root 2 plus square root of 4 is 2. 2 times root 2, that is 2 root 2. 3 of this plus 2 of it, that gives us what? 5 of it. That means 3 root 2 plus 2 root 2 gives 5 root 2. That's the end of that. You can see it is simple to understand. Let's move to example 2. Example 2. Evaluate root 27 minus root 12. As I said the other time, a layman will say root 27 minus root 12 is root 15. Don't do that. It will be wrong to do that. Simplify root 27 to be root 9 times root 3 in brackets minus, simplify root 12 to be root 4 times root 3. Square root of 9 is 3. 3 times root 3, that gives us 3 root 3 minus, square root of 4 is 2. 2 times root 3, that is 2 root 3. You want to subtract 2 of something from 3 of its kind. It will remain 1 of such thing. So subtracting 2 root 3 from 3 root 3 gives us 1 root 3. And that 1 root 3 is written as just root 3. But it means 1 root 3. Only 1 root 3. And that's the end of that. Example 3. If root 50 plus p root 2 is equal to root 128, find p. What do? The same process. Simplify each surd. To simplify root 50, you have root 25 times root 2. 25 is the perfect square that we have in 50. So, plus p root 2 equals, you break 128 into factors. 1, 2, 8. 2 in 12, 6. In 8, 4. You can see that 128 could be 2 times 64. So that 64 is a perfect square, don't forget. So it is square root of 64 times square root of 2. So square root of 25 here is 5. 5 times root 2 gives 5 root 2 plus p root 2 equals, square root of 64 is 8. 8 times root 2, that gives 8 root 2. You collect the like terms in this. Pure surd, this is algebraic surd. Surd with unknown value, representative of a number. So you separate them to have p root 2 equals 8 root 2 minus 5 root 2 by collecting the like terms. So you have p root 2 being equal to, when you subtract 5 root 2 from 8 root 2, it gives you 3 root 2. So you have 3 root 2 here. To know the actual value of p, you divide both sides by root 2. Dividing both sides by root 2, you have p root 2 divided by root 2 gives 3 root 2 divided by root 2. You can see that root 2 will cancel root 2 here to give us p. Root 2 will cancel root 2 here to give us 3. So the value of p is 3. That is the end of example 3. Here we come to another subheading in surds. Multiplication of surds. Example 1. Simplify root 3 raised to power 5 times root 6. Root 3 raised to power 5 means root 3 times root 3 times root 3 times root 3 times root 3. That means root 3 in 5 places. 1, 2, 3, 4, 5. Times, you break root 6 into factors. Root 3 times root 2. So, root 3 times root 3 gives 3. Don't forget the rule. Root 3 times root 3 gives us another 3. Times root 3 times root 3 gives us another 3. Times root 2. 3 times 3 is 9. 9 times 3 is 27. 27 times root 2 gives 27 root 2. And that's the end of example 1 under multiplication of surds. Example 2 under multiplication of surds. Evaluate root 15 times root 6 times root 2. All you need to do is break every surd into factors. Like root 15 is root 3 times root 5 times this root 6 is root 3 times root 2. Then we have root 2 on its own, root 2. So you can see that root 3 times root 3 gives us 3 times root 2 times root 2 gives us 2 times the only one thing left unused there is root 5. Do you understand? 3 times 2 is 6. 6 times root 5, that is 6 root 5. And that is how to handle something like this. Example 3, under multiplication of surds. Evaluate root 10 times root 14 times root 21. Break root 10 into root 5 times root 2. Then root 14, break it into root 2 times root 7. Break 21 into root 7 times root 3. You can see now that root 2 times root 2 will give us 2 times root 7 times root 7 gives us 7 times root 5 times root 3. Don't forget, it is when you have root A times root A that the answer is A. But if you have root A times root B, answer is root AB, the root of the product of the two different values. So 2 times 7 is 14 times root 5 times root 3 should be root 15. And finally, it is 14 root 15. And that's the end of that question. We move straight to the next example. Let's consider the last example I have for you under multiplication of surds. Example 4. Evaluate root 18 times root 8 times root 6 times root 2 raised to power 3 times root 3. Breaking root 18 into root 9 times root 2 times break root 8 to root 4 times root 2 times break root 6 to root 3 times root 2. And root 2 raised to power 3 means root 2 times root 2 times root 2. Then the last one, root 3. Square root of 9. Square root of 9 is 3. 3 times root 2, that is 3 root 2. Times square root of 4 is 2. 2 times root 2, that's 2 root 2. Times root 3 times root 2 times root 2 times root 2 times root 2 times root 3. From this, you remember 3 times 2 is 6 times root 2 times root 2 is 2. I hope you are getting what I'm doing. You first multiply 3 times 2, 6, times Root 2 times root 2 is 2 times root 3 times root 3, that is 3. Again, root 2 times root 2, that's 2. Also, root 2 times root 2 is another 2. There is no surd left on the board. We've turned everything to ordinary number. So, we have 6 times 2, that's 12, times 12. 3 times 2 is 6. 6 times 2 is 12. So 12 times 12 is 144. That is the end of the last example under multiplication of surds.